Hello everyone, and today on the bench we have a Williams Flash Gordon CPU board for a pinball machine. I'm actually quite surprised. I've had quite a few Flash Gordon boards this year already, so I don't know why that is. It seems to be a lot of people trying to repair Flash Gordons. Anyway, don't know what's wrong with the board, but I've had a quick initial inspection, and board's in generally decent enough condition, but it looks like we've had some corrosion all around here. And I'm not sure how well you can see that. A bit of corrosion I can see under that socket. So I think we're going to be, well, these sockets are not particularly pleasant looking ones, so I think we're going to be pulling off sockets in this area and this chip here. I think these headers probably want replacing as well. They're not looking the best. Looks like we've got a new socket on the RAM, new socket on the CPU. So we can test out the CPU and the RAM, make sure they're good. Get these sockets out, then we need to get some ROMs installed. Or at least a test ROM, and then we can see what the game does. Does it boot up or not? Right, so I've pulled off that first ROM socket there, and you can see we've got quite a bit of corrosion, got blue residue and powder. So I'm suspecting that it's going to be similar under at least these two. So I'm going to carry on pulling these sockets off. After that's done, I'm going to give it a neutralisation wash. It's not that bad. It hasn't eaten right into the copper. So I think... oh, focus there. Yeah, light neutralisation and a light sanding, and that should be good to go. Not too bad really. So once we've neutralised the problem areas, we can then look at actually diagnosing the faults on the board. Right, so I've taken out the rest of these ROM sockets, and if we have a close look, we can see we've got corrosion under the far left two, maybe a slight amount of corrosion on the third. The other two are not so bad at all. Now, we needed to take these three out anyway, because we're going to replace these with turn pin sockets before we put the new ROMs in. These three here will not be replaced, but we are going to neutralise them so they don't cause any further damage. Okay, so we've got the test ROM in the board, and let's power up both 5 and 12 volt. And we're getting two static LEDs, so this is not booting up. We're getting some further checking around the CPU now to see what's going on. Well, I have to be a little bit suspicious of this buffer here on the address bus, as it's getting pretty hot. So let's just do a reading on a normal one, 37. Let's just get over that one. And we've got a peak temperature of 71. So high 60s to low 70s we're getting on that chip. That seems far too hot. I can't even touch it. If I touch it at that temperature, it's going to take my skin off. These front packages are quite nasty for that. So I think there's going to be something wrong with that, almost definitely. Right, I've got the test clip hooked up on that IC there, the one that's getting hot. And looks like my suspicions may be correct. As you can see there, we are seeing a short to 5 volts on pin 11. Let's get the schematic. Pin 11, that's A4. So address line 4 is shorted to 5 volts there. That's probably why the chip is getting so hot. So let's find out why that's happening. Is it internally in the chip, or is it somewhere else on the board? Okay, so we've made some progress. I've fitted a 10-pin socket. I've obviously taken off the original chip. Put a chip in that I've taken off another board, which is the 97T. Put it into the tester and focus. The short to 5 volts gone, and the overall result is now a pass. So that is now working. Well, the game's probably not working, but that chip is now working. We should not have a short on A4 anymore. Okay, so I put the chips back in, powered it up. Unfortunately, still the same, still locked up. Kind of thought it would be, but I was curious to see what would happen. One thing I've actually noticed is the board is now drawing 200 milliamps less than it was. It was drawing 1020, now it's drawing 820, so about 200 milliamps that short was using up. That's why that chip was getting to 70 degrees. Anyway, what we're going to do now we've got the board in a bit of a better state, I'm going to carry on probing basically the address and data bus lines with my oscilloscope, and we can see if anything funny is going on anywhere else. Okay, so I noticed that one of the address lines on the external side looks a bit iffy, so what I've done is I've hooked up some grabbers to the in and the out on the buffer, These are connected to some meter-long test leads coming to some adapters, which I've then clipped my scope probes onto. That's probably the worst way of getting a clean signal ever, but that's basically all I had to hand. I'm going to have to get myself some grabbers to BNC basically to allow me to do this in the future. Anyway, so here we've got sort of jumpy picture. Now I'm going to try and get a decent grab of this, because what's not obvious this minute is the yellow is basically showing high lines, whereas the blue is showing spikes only. So it's like the high pulse is missing. Something's not quite right with that. So what I need to do, I'll try and grab some data and we'll have a proper look at it. Okay, so I've managed to single shot grab some data. Let's just bring that into view. Don't turn away. Right, there we go. That's showing it fairly clearly. So yellow is CPU side, I believe. Let me just verify that. Blue is, red is there. Yes, okay, so yellow is CPU side. Blue is external bus side. Not really work any further than that. Let's have a quick scroll around. So during this high period on the CPU side, we have these spikes. Let's have a look what we're looking at here. So we're looking at a 4.6 volt peak to peak there. So yeah, this is the inputs and outputs are not behaving the same on that one. Not at all. Let's oops, didn't mean to move that out then. Let's just look a bit more. Yeah, see, it's I repeat it a lot. Same thing all the way through. Big spike on the blue, not on the yellow. So CPU side's high and the external side's pulsing. Right, I've done some more captures to get something else to look at. So we've got something different here. Let's zoom into one of those. Okay, right, yeah, it should be fairly obvious. Let's just turn off channel 1. So that's the CPU side. That there, the blue, is the external bus side. Yeah, you've got one little spike and a fairly big spike. Switch on the CPU side and you can see it's actually, that's a high pulse, then back to low. But we're getting just this little spike here, a little spike here. So it's basically, it's like the output is sort of triggering on the edges. Something isn't doing what it's supposed to be doing. That should be a high pulse. I don't think that's going to be sufficient at all. That's certainly going to mess the timing up. So we need to look at why it's doing that. Right, I've tried a different buffer chip. I've just done another capture, got it into screen for you, and you can see same sort of thing happening. So something on the external side is causing that rather than the buffer itself. Right, so I'm hooked up to A3 to see if we can compare a valid input and output. So it's running now. Let's capture one. And we'll just zoom in. And there we go. So as we can see there, very slight propagation delay and a slight difference in the levels on the inputs and outputs, but that's basically mirroring the outputs mirroring the input as we expect. So that's what valid looks like. Right, one more time we're connected up to A5. Let's see what we got. So red is on the input, the CPU side. That goes to the yellow trace. So yellow trace is CPU side, blue is the buffered bus side. So let's see if we can capture a decent frame. There we go. Zoom in. Yep, so the last time we're looking, you see the input rises. We'll just turn off the output. So input rises, you've got like almost a square wave there. And the output is basically just a couple of pulses. So something on the buffered bus side is dragging that down. We need to find out what that is. Right, the next thing I've done now is I've removed the two 6810 RAMs and fitted sockets in its place. Now, if we have a look at the scope, let's just grab a... There we go. Excuse me. If we look now, we're actually getting the same square wave on the input and the output. And the other telltale sign that it's actually working now is that the lights are now flashing. So what we can do is we can basically start repopulating the rest of the board and test it again. Well, we've obviously got one of these two RAMs has a shorted A5. Let's find out which one it is. Okay, so that looks like it's testing away happily. One thing we've got to do is just do the RAM test. So we should see one pulse, and two pulses. 1, 1, and 2. There you go. Yep, so all the RAMs are fine now. One thing I need to do is I need to change this for an NVRAM for the customer and then test that as well. When that's done, we need to connect this up to the drive board, and then we need to also test it with displays. But it looks like it's running fine now. Right, so the next phase of testing, we need to connect up a driver board, because to put game ROMs in, we need these PIAs here on the driver board to be present and working, otherwise the game can't boot. While I'm doing this video, this is a weird driver board. Just have a quick look at it. I know it's got some chips missing because it's in the middle of being repaired. Does anyone know what game or games this board comes from? It's a 5763 094600 model number. That is not a standard System 3 to 7 board. No, neither is it a Hyperball board, so I don't know what this version is, as I've never seen one before, and obviously googling it didn't give me any results. So anyone any ideas? Basically, we've got an extra chip here, we've got a couple of extra chips here, which these again, they're not fitted yet. You can see the lamp circuitry is significantly different, and the reflexive coils circuitry here is also different. So, anyone have ideas? Let me know about that one. Anyway, what we're going to do now is put the ROMs in for the game, and then we should be able to boot it up. I also need to get my display tester so we can see what the game's doing. Right, so I've hooked up the display test, and let's just get a focus on that. It's just showing garbage on the displays. Let's just toggle power. No, it's not running the game code, or at least it's just outputting garbage. So I need to do some further investigation there. Okay, so I took out that NVRAM module and put back in the original RAM. Bear in mind, this is not one of mine, this is one that the customer provided. If we have a look at the display, come on, focus. We can see it's actually running a track mode absolutely fine there. It's basically cycling the default high score. So, something's either wrong with this, or it's got some junk data in it that stop it from booting properly. Right, I found some further weirdness. So this is with the RAM in. Power up. We get a track mode. And if I press the test button, it's basically locked up now. It's no longer showing a track mode. I can press it as many times as I want. Flip the switch. And nothing. It's basically crashed. Okay, so this is a known good driver board. This is the CPU board with the game ROMs installed. And power up. It basically powers up into a locked up state. So it does not run with this working driver board. So there's still an issue with this CPU board. Right, without the driver board, the game is booting and running the test again, which to me indicates the driver board's probably pulling down one of the address or data lines. So we've probably got bad buffer again somewhere. Right, after scoping out the signals on the driver board, I noticed some of them were a bit weak. So I basically worked out that the connectors on the CPU board that go to the driver board were in poor condition. So I've desoldered them to replace them. They're actually very hard to melt the solder, and we can see the solder is actually corroded in several places. So there's been corrosion trapped under here in the past, so we need to get all that cleaned up before we put the new connectors on. Okay, so as you can see, the new pin headers are on, they're all lined up properly, and now we're going to try with the driver board again. And there you go, driver board connected, we've got the lights flashing, so the test is running, and we've got the relay clicking, so we know the blanking is also working. Now let's try again with the games ROMs. Now I can't get this NVRAM module to work no matter what I try. Let's power it up. We're just basically getting static LEDs and nothing on the display. So I don't know what's up with that, it just will not work. Right, it has been a considerable amount of time since the last video on this. Now I had to put this back on the shelf and work on some other boards, as this was delaying my work queue. It was just taking far too long to fix. Nothing simple with this one. Anyway, it's been back on the bench. I'm about 3 or 4 hours in again, and I've been analysing every single signal on the board with the scope. I even pulled out my Gorgar board. I've been comparing signals, and I've been looking at absolute fine detail. I noticed a very, very, very slight difference in the timing on the it was the select and the read write going to the 5101 RAM compared to the Gorgar. Very, very slight, but I've basically replaced the 7408 and the 7404 at ICs, that's 12 and 7. And that has basically brought the timing in line with the Gorgar board. So I've just rebooted the board. If you look on the display test, you can see it's actually got into test mode now. It's running. Previously we couldn't get into test mode because when we power the game up it goes into audits because the battery pack RAM is in an unknown state. What you normally do is you flick the power on and off and that resets it, but this would not reset because the read, write and select timing was slightly out, so it wasn't actually able to write valid data into the RAM. So it is now, and it is booted, and it is in test mode. We can see we have another problem to deal with. We've got alternate digits missing that are just sat at 0. So we're going to have a look at that now in this area here. Hopefully, if we get that resolved, that might be everything. The strobes come out of this 74154 here, and if we look at pin 1, we've got a stuck high signal. Pin 2 we're seeing a valid signal, 3 stuck high, 4 valid signal, so it looks like alternate bits are actually missing. That kind of indicates the least significant bit input's not working. So if we look at the schematic and pin 23, so we've got pin 20, pin 21, pin 22, and pin 23. Yeah, that's not a valid looking signal. Okay, so it is the least significant bit is wrong. Let's check that out further up in the chain. To the schematic, the next up in the chain is pin 2 of the PIA, and we've got the crappy high signal with noise on it again. So annoyingly, it looks like the PIA is bad, and it's another blooming chip I've got to desolder. Now before desoldering the PIA, I thought I'd stick the Leon test ROM back in, which is pulsing every PIA output. So let's just have a quick look. So pin 2 is the one that's stuck high, and now we can see it's actually pulsing. So it's possibly not the PIA that's bad, as nothing is straightforward with this damn board. Right, let's have a look where we're up to now. So here's the game running in attract mode. We can see the high score appearing and disappearing intermittently as it does in attract. Let's just get into test mode. Okay. Now you can see all the digits are working. Now originally I basically tried putting another PA over the top and bending out pin 2, and it wasn't showing any output either, so I thought okay, it's not the PA that's the problem. But after checking a few other things and not finding a solution, I ended up socketing the PA and removing the original, putting a new one in, and that's fixed that problem. Also along the way we replaced this address buffer here, and we also bypassed the data bus drivers, which is a common thing to do on these old Williams boards. Now I haven't actually checked if this is still the case, but the original chip here is an 8097 bus driver. They're no longer manufactured and hard to get, so I put in a 74LS 367. Originally that didn't work, so I basically double stacked them, and the reason why it wasn't working because it wasn't providing enough current to drive the outputs. Now I'll show you this PIA. I'm just going to try removing one of these, and it's still working. Okay, so potentially one of the problems was that this PIA here, well the original one, sorry, was putting a strain on the address bus, as it's now working with a single 367. A few more checks to do, but I think this might be fixed now. If it is, I'm going to celebrate with a beer because this is taking forever. Yeah, that does not work. So LEDs are locked up, nothing on the display. Let's just check it's in firmly. We'll cycle the power. No, locked up. Try it a couple more times. Yep, this NVRAM does not work. Okay, so this is the board finally finished. We've got the old 5101 RAM back in because we don't have an NVRAM with the CS2 select line on it. So we need that for the old System 3 and 4s and the Gottlieb boards. So we can see it's in a track mode. Let's just do test mode one more time. There's your display test, our lamp test, and that's solenoid test. So we can see it's all working nicely. Now we'll just power cycle, and we're back into track mode again. So this board is now ready to go after extensive work. This has been, I thought the last flash board I had was the worst. This is now the new worst. So I don't think I want to do any more flash boards. I have no idea why, but they always seem to be completely screwed up when I get them. Anyway, hopefully this is it, all done.